In 6.6, we're going to be talking about function operations. So before we get started here, these are all the different function operations that you could have: addition, subtraction, multiplication, and division. So I'm going to pause this video, write all these down real quick just to have them in your notes. Also, just make a note here for division. When I'm dividing two polynomials or two expressions, it's important that that denominator is not 0. Because remember, whenever I try to divide by 0, it's undefined, okay? So that's going to become important when we start to do some of these example problems. Also, you want to write down the domains of the sum, difference, product, and quotient functions consist of the x values that are in the domains of both f and g. So you're looking for a common domain between the two of them. Another important note here, again, make sure to write this down because this is going to come up in the next example that we do, or 2 examples from now. You'll see this eventually. The domain of a quotient function must exclude any x value for which g of x would be 0 in the original f over g expression. So basically what that's saying is that before I simplify f of x over g of x, whatever would make that denominator become 0 in the original expression, I need to exclude from my final domain. So let's look at one example here. F of x is 4x plus 7. G of x is the square root of x plus x. And from here, to do my function operation, I want to find f plus g, f minus g, and then finally their domains. If I want to do f plus g, another way I could look at this is f plus g of x, or another way I could write that, f of x plus g of x. And then literally all I'm doing here is I'm just adding those two functions together. So I'm looking at that, I'm combining like terms. F plus g of x would be 5x plus the square root of x plus 7. If I wanted to subtract these, it would kind of go the same way. Except now that I'm dealing with subtraction, I'm going to put these in parentheses just to deal with that subtraction sign, make sure I carry it to both terms. When I combine like terms here, I'm going to get 3x minus the square root of x plus 7. So those are what my functions would be. Now I want to figure out the domain. So the domain of f of x is all real numbers because I could literally plug in anything for x in f of x and it's going to spit out an answer for me. G of x is a little different. G of x is going to be all numbers greater than or equal to 0 because I have that square root there. So keep in mind, I'm kind of staying within the realm of real numbers here. I'm not really going to go into imaginary. If I tried to put a negative number in for x, it would not spit out a real answer for me. It would have to be imaginary. So that's why I'm going to say my domain is all real numbers of x greater than or equal to 0. Now looking at that, I want to find a common domain. Now you might look at that and already know what numbers they share. Sometimes it might be helpful to look at this on a number line. So I have a number line. All real numbers is just everything. All numbers 0 or higher, I would mark like that. And that overlap there is the domain in common. So your common domain for both of these is going to be all real numbers x greater than or equal to 0. Which just looking at those functions makes sense because since I have a radical x in both of those, that's my kind of limiting factor there where I need to have all numbers, I need to have all non-negative numbers. That's all that's going to work in that function, or both of those functions. Now let's look at some different examples. I have f of x is x squared minus 9 and g of x is x plus 3. I want to figure out f times g and f over g, and then finally their domains. F times g, kind of same as the other problems, I just multiply those two functions together. Here, since I have two binomials, I'm going to have to FOIL. So I get x cubed plus 3x squared minus 9x minus 27. Nothing simplifies here, so that's my answer for f times g of x. For f over g, I'm going to do x squared minus 9 over x plus 3. And now looking at that, so that's my original equation, keep that in mind. But if I wanted to try to simplify this, x squared minus 9 could expand to give me x plus 3 times x minus 3. Now I see that the top and bottom cancel each other out, so my final simplified answer for f of x over g of x would be x minus 3. Now let's take a look at their domains. The domain for f of x and g of x is all real numbers because I could plug in anything for x for both of these, f or g of x, and I'm going to get a number spit back out. So f times g of x is pretty easy. That's also just going to be all real numbers, which again, looking at that function makes sense. There's no number that wouldn't work when you plug it in here. The thing that I want to pay attention to here is f over g. So as you wrote earlier in the notes, f divided by g of x, like I need to pay attention to the original expression. I can't have the denominator be 0. And what I want to do is I need to focus on that original f of x over g of x. And that's what I'm going to focus on for thinking, okay, what numbers would make g of x be 0? Looking at that original equation, -3 would make the denominator be 0. So my domain for f of x over g of x is going to be all real numbers except for x equals -3. Again, it's important that we focus on the original equation here. If I just looked at that simplified answer, I wouldn't be able to determine any exclusions from the domain. Finally, last thing we're going to talk about today is composite functions. I think these are really interesting. So g of f of x, sometimes you'll see with that little hollow dot there, and it just basically means a function inside of a function. Your game plan to solve these, or if I had g of f of x, is I would want to find f of x first. Whatever value I get, I plug that into the g of x equation and then solve. So let's look at an example here. F of x is x minus 5, g of x is x squared. I want to find g of f of -3. So a way that you could rewrite this to maybe have this look a little bit easier is rewrite this as g of f of -3. Now I'm just going to focus on the inside for now. F of -3, I look at that equation, and I just plug in -3. -3 minus 5 gives me -8. Now, I look at g of x and I solve when I plug in -8. -8 squared gives me 64, and I'm done. Now, you might be thinking it doesn't really matter what order I plug these in. So let's reverse that. What if I wanted to find f of g of -3? What I would do here is I would do f of g of -3. I could write it that way. G of -3 is -3 squared, which is 9. F of 9 would be 9 minus 5, which gives me 4. So you could clearly see here that depending on what order that composite function's in, that's going to change my final answer there. So it's important to kind of note, look at the pattern there of like what function you should start with those kinds of functions. And that's it for this section.